Hey YouTube, this is Brendan with Cusack Prep, and in this video we're going to be discussing instantaneous speed, velocity, and acceleration as it pertains to AP Physics C. We will be talking about these concepts in terms of calculus, so if you haven't taken calculus or if you're not in AP Physics C, probably not the video you want to watch. Well, let's go ahead and get started. So instantaneous speed, we have to remember first what speed is. Speed, which is often denoted by s, is equal to your distance divided by time. Now we're going to contrast that with velocity. Velocity is equal to your change in displacement over your change in time. So you might say, okay, Brendan, like those two things, what's different about them? What's the difference between distance and the displacement? And the answer is sometimes nothing. It is possible for your distance and your displacement to be the exact same value, but oftentimes it's not the case. So distance is the total amount that you have traveled. So it's how far you've gone, whereas displacement is just the change from your current position to what your position was when you started, or your final position minus your initial position. So to demonstrate that difference, we can imagine we have a track. So let's just say we have let's use an oval, and we just have a track, something that looks like this. Now let's say you were to do one full loop around that track, and a track is about a quarter of a mile. So we're going to say, okay, we travel a quarter of a mile as we go all the way around the loop. So one full lap around the loop, well, that's going to move us a quarter of a mile. And that's going to be our distance. As I go from here to here to here to here, and then back to this position, I've traveled 1/4 of a mile. So my distance is 1/4 of a mile. But my displacement, as I go from here all the way back to here, is actually 0. Because I have not changed my position. My current position is the exact same as my previous position. So, well, what gives with that? Well, then our speed would just be 1/4 of a mile divided by how long it took us to run. Maybe it was 2 minutes or 120 seconds. Whereas our velocity would be our change in our displacement over a change in time. So in this particular example, let's say it took us 2 minutes or 120 seconds. It would be 0 divided by 120 seconds. So our velocity, or our average velocity over that period, is 0. On the other hand, our speed, a quarter of a mile is about 400 meters. So I'm going to use standard units divided by 120 seconds. And that would be 10 over 3 meters per second. So we can see that speed and velocity in this particular instance are different from each other, and they oftentimes are. But just know that speed is your distance over your time, velocity is your change in displacement over your change in time. So let's talk about how calculus comes into this. Well, the word instantaneous, when dealing with instantaneous speed or instantaneous velocity or instantaneous acceleration, just means at that exact moment in time. What we did here is we calculated averages because we took some value sometime later and subtracted it and then divided it by the time. So that's average speed, and that's average velocity. But what about instantaneous velocity? Well, instantaneous velocity is defined as the limit as t approaches 0 of delta x over delta t. Now, what does this mean? This means that your change in time, or as delta t approaches 0, is exactly that very brief instant in time. So we're looking at what is our speed exactly at 2 seconds, not what is our average speed between 1 second and 3 seconds. But if we were to take a radar gun and point it at a baseball or something else, exactly 2 seconds, how fast is it going? Now, a radar gun actually measures average speed, but it does so over such a small interval of time that we can effectively say it's instantaneous. This is also can be written as dx dt. All right, so that's how you define velocity. It's the limit as delta t approaches 0, the change in x over the change in time. It's also written as dx dt. I'll post some additional examples in a future video of how we can apply that. Now, what is speed? Well, instantaneous speed is just the magnitude or the absolute value of the velocity. It's important to know that speed is a scalar, whereas velocity is a vector. But if we take the magnitude of a vector, we get a scalar. And why does this make sense? Well, as I went all the way around this loop here, my displacement was 0, and my distance was 400 meters. But if I look at just one particular point, let's say I look right here, and I try to figure out what the speed is. Well, if I point a radar gun, maybe this guy is running 3 meters per second, 10 miles per hour, anything like that. And his speed and his velocity are essentially the exact same thing, except that velocity has direction and speed doesn't. So the speed would be 10 miles per hour. The velocity would be 10 miles per hour to the north, or to the south, or to the east, or to the west, depending where on the track that he is. And then finally, we can take a look at acceleration. So if we remember, acceleration is the change in velocity over the change in time. So instantaneous acceleration can also be discussed in terms of derivatives. So a sub t is going to equal the limit as delta t approaches 0 of the change in velocity over the change in time. So once again, it's at that very instant in time that we're looking at. What's the acceleration in exactly 2 seconds? What's it at 10 seconds or 5 seconds? It's at that exact moment. And this is going to be equal to dv divided by dt, which is the first derivative of velocity with respect to time. Now, we can go ahead and put all these together, and we'll just kind of summarize it nicely down here. And that's to say that the acceleration is the first derivative of the velocity with respect to time. So we could say it's equal to dv sub t with respect to t. And the displacement is it'd be the second derivative of displacement, so d squared x of t over dt squared. And that's kind of a brief introduction into what instantaneous speed, velocity, and acceleration are. In the next video, I'm going to show you some examples of how, if we're presented with an equation that describes the velocity, how we can use that to find the acceleration at a specific time, or if we're given the displacement, how we could use that to figure out the velocity and then the acceleration. Thank you for watching. Hope you found this video helpful.